This is example 5. Again, it's dealing with bearing, and we know what bearing means now. It's the number of degrees east or west of a straight north-south line. Right, this one is telling us, and we can walk our way through on the picture, that a ship leaves port at noon and heads due west at 20 knots. I believe you'll follow my cursor here. Due west at 20 knots, that means 20 nautical miles per hour. At 2 p.m., that means after 2 hours, it changes direction to north, 54 degrees west, as shown in the figure. And at 3 p.m., which is 1 hour later, it's somewhere up here. They're saying find the ship's bearing and distance from the port at 3 p.m. Right, well, the bearing and distance from the port, there's the port. There's the location it is at 3 p.m. So the bearing would be relative to a straight north line. It is some number of degrees to the west. So we know we're looking at the bearing is going to be north some number of degrees west. Right? And the distance is going to be the length of sea. So there's a lot of pieces here we've got to put together. And I'm going to follow the directions or the example in the book. This may not have come to you intuitively at the beginning, but with trial and error, you could probably have figured this out. So let me go to the next slide. Again, we are trying to find this distance or this angle. That'll give us our bearing, and we are trying to find C. Right, so the first thing that we can say is that this angle is 36 degrees because these two together must be 90 degrees. There's 36 degrees. Okay. Based on that, I can find the values of B and D. Right? It should be that the sine of 36 is B divided by 20. The cosine of 36 is D divided by 20. So I'm going to save a little step here. I'll say B equals 20 sine 36. And I'm doing that with my calculator in hand. 20 sine 36. 11.8. I'm going to round to one decimal place. 11.8. And D then would equal 20 cosine of 36. And that looks like 16.2. So let me write that in. This is 16.2. This is 16.2. And this is 11.8. Okay, now based on that I know that this entire length from capital C all the way over to capital A is going to be 40 nautical miles plus 16.2. So this side of the triangle is 56.2. And now we can solve for this angle, whatever it is. I'll call it theta, because the tangent of theta should be the opposite over the hypotenuse. So theta is equals tan inverse of 11.8 divided by 56.2. So second tan inverse 11.8 divided by 56.2. Looks like it's about 11.9 degrees. Right. But if this angle is 11.9 degrees, then we know what this angle then is, because that would be 90 minus 11.9, so that is 78.1 degrees. So now we know our bearing. Our bearing, the ship's bearing at 3 p.m. is north 78.1 west. Okay. Now we need to find this distance, the c. And I believe in the book they did this as a trig problem, but honestly, we know that we can use Pythagorean theorem now. We know this side of the big triangle, and we know this side of the big triangle, so let's just use Pythagorean theorem. The c will equal the square root of 11.8 squared plus 56.2 squared. C equals second square root 11.8 squared plus 56.2 squared equals 57.4. Does that look right? It went 40 miles this way, went 20 miles that way. That looks about right. C equals 57.4 nautical miles.